Studies Section 3. Theory of Production. Introduction. Just as the consumer maximizes utility, the producer also maximizes profit either by minimizing cost or maximizing output. In this studies section, you will explore the theory of production. Specifically, you will examine how producers attempt to maximize profits. Learning outcomes. When you have studied this section, you should be able to discuss the meaning of production, point out the locus of technically efficient methods, discuss the expenditure line of production, outline the 3 stages of production in the short run, explain the meaning of income consumption curve, carry out long-run analysis of production. Production in economics is broader in scope and meaning than it is often assumed. It is concerned with any activity which creates economic value. It does not only imply the process of fabricating commodities, but also covers any activity concerned with the packaging, storage, marketing of these products. Production function. A firm's production function represents the technology available to that firm within an industry. It therefore includes all the technically efficient methods of production. Technically speaking, it is relationship between the rate of flow of output and the rate of flow of corresponding input used to produce it, given existing technology. It can be expressed mathematically as Q is equal to F bracket open x1, x2, x3, xn bracket closed, where x1, x2, xn represent quantities of various inputs and Q represent the quantity of goods produced per unit of time. Production process. This involves the combined system of activities by which various inputs are converted into material goods and services per unit of time. Various methods and techniques of production can be adopted to produce these goods and services. A firm may decide to use more capital relative to labor. This is called capital-intensive technique of production. Also, more labor may be employed relative to capital. This is referred to as labor-intensive technique of production. The choice of any particular technique is an economic one, usually based on prices. Question. Define a production function. Feedback. Production function is a statistical relationship between output and the factor input needed to produce it, which reflects the technology of a process of production. Isoquant. Isoquant is the locus of all the technically efficient methods or all the combinations of factors of production, e.g., capital and labor, capable of producing the same level of output. It is the producer's equivalent of the consumer's indifference curve. The slope of the isoquant bracket open minus decay dl bracket closed defines the degree of substitutability of the factors of production as shown in the diagram above. The slope of the isoquant is called the marginal rate of technical substitution of the factors MRTS. Minus dkdl is equal to MRSLK. The slope of the isoquant decreases in absolute terms as we move downwards along the isoquant, showing the increasing difficulty in substituting capital K for labor L. Given the production function. Production function is equal to F bracket open K L bracket close. Equation 1. Taking a total differential of both sides of equation 1. The production function is equal to Fk decay plus FL dl is equal to 0. Fk dk is equal to minus FL dl minus dk dl is equal to FL over Fk is equal to MRTS, where FL over Fk is the ratio of input prices. However, this production isoquant may assume various shapes depending on the degree of substitutability of factors. 1. Linear isoquant. It is an isoquant which assumes perfect substitutability of factors of production. 2. Input-output isoquant. This assumes zero substitutability of factors of production, or what may be referred to as strict complementarity. 3. Kinked isoquant. This is an isoquant which assumes limited substitutability of capital and labor. 4. Smooth convex isoquant. This also assumes continuous substitutability of capital and labor only over a certain range, beyond which factors cannot substitute each other. Several isoquants are possible on the input space. The further the isoquant from the origin, the more output it can produce. A higher isoquant will always be preferred to a lower one. However, this choice is limited by the isocost line as discussed below. Question. Isoquant for producer is equivalent to the indifference curve of consumer, true or false? Feedback. True. Isocost. Isocost can be defined as a combination of two inputs that can be used to produce a given level of output, given the price of each input and the available level of technology. The isocost or expenditure line is the combination of inputs that just exhausts total expenditure. This simply implies the combination of inputs that can be used to produce a given level of output, given the cost outlay as well as the price of each input. It is represented as C is equal to RK plus WL. Equation 2. Total cost is equal to interest paid on capital multiplied by the units of capital plus wage rate multiplied by labor units, where C is the total cost expended on factor input, K is the capital, L is equal to labor, R is equal to interest paid on capital, wage paid on labor. C is equal to RK plus WL. dC is equal to R dk plus W dl is equal to 0. R dk is equal to minus W dl. Minus dk dl is equal to W over R. At equilibrium, minus dk dl is equal to FL over Fk is equal to W over R. MRTS is equal to W over R. Equation 3 shows the optimum input mix because it represents a point where the isocost line is tangential to the isoquant. It can be demonstrated geometrically as follows. The equimarginal principle in production or efficiency criteria is given by MPL over MPK is equal to PK over PL by cross-multiplying MPL.PL is equal to MPK.PK for n inputs. 1. PAXA plus PBXB plus PNXN is equal to TC. 2. MPXA over PXA is equal to MPXB over PXB is equal to MPXN over PXN. Question. Distinguish between isoquant and isocost. Feedback. Isoquant is a curve showing different minimum combinations of two factors of production producing the same level of output, while isocost is a straight line showing different combinations of two factors of production for the same cost. Economic region of production. The basic production theory concentrates only on the efficient part of the production function. The efficient part occurs on the range of output over which the marginal products of the factors are positive. No rational firm would employ labor beyond ON because beyond ON any factor input employment would result in the reduction of the total output of the firm. Alternatively, the theory concentrates on levels of employment of the factors over which their marginal products are positive but decrease. MPL is greater than 0, but the MPL DL is less than 0. This can also be represented using ridge lines. The locus of point of isoquant where the marginal product of the factors are 0 form the ridge lines. Production techniques are only efficient inside the ridge lines. The lower ridge line implies that marginal product of labor is 0. The upper ridge line implies that the marginal product of capital is 0. Thus, efficient production techniques take place inside the ridge lines. Marginal product of factors are negative and methods of production are inefficient outside the ridge lines since more quantity of factors are required for producing a given level of output. The economically feasible region of production corresponds to stage 2 of production stages when total product is increasing while marginal product is decreasing. In stage 1, production conforms to the region of rising average cost. Marginal product is also rising and exceeds average product. Stage 2 represents the economic region of operation where both marginal product and average product decline continuously but neither reaches 0. Total product continues to increase and attain the maximum point when MP is equal to 0. Stage 3 is characterized by declining marginal products. Expansion parts. The major objective of an entrepreneur is to maximize profit. He must thus organize production in the most efficient way. Expansion part is the locus of optimum input combinations for each possible rate of output when the prices of input remain constant and consumer income varies. This is also known as income consumption curve, ICC. At point A, B, and C, the rate at which a firm substitutes one factor input for another is constant. That is, MRTS is constant. The production expansion part also represents an isocost. An isocost can be defined as a locus of points along which the MRTS is constant. This can assume any shape. However, the two are not the same. While an expansion part is an economically most efficient rate of expansion, an isocost is the locus of input combinations that yield the same MRTS. A production expansion part can be technically efficient as well as remain an isocost, but no isocost is automatically a production expansion path. Return to scale. This is a long-run analysis of production. In the long run, all factor inputs are variable. In this long run, output may be increased by changing all factors by the same proportion or by different proportions. Three different cases are possible: increasing returns to scale, constant returns to scale, and decreasing returns to scale. Increasing returns to scale. This refers to a situation whereby the proportionate change in output is more than the proportional change in input. Output has more than double relative to increase in input. Figure 3.8 shows that the output response is equal to that of input. This is called constant returns to scale. Under constant returns to scale, output and input will increase by the same proportion. Figure 3.9 shows decreasing returns to scale since an increase in input leads to less than proportionate increase in output. Output will increase but not in the same proportion as input. Returns to scale and homogeneous fraction. Homogeneous fraction one which allows k to be factored out of the fraction after it has multiplied each of the inputs in that fraction. If k cannot be factored out, the production fraction is known as non-homogeneous. If k is powered by v, it is called the degree of homogeneity of the fraction. If v is equal to 1, we have constant returns to scale. This can also be regarded as linear homogeneous. If v is less than 1, we have decreasing returns to scale. If v is greater than 1, we have increasing returns to scale. Example: suppose we have the production function q is equal to 2x plus 3y. Q is equal to 2 bracket open vx bracket close plus 3 bracket open vy bracket closed. Q is equal to bracket open vq bracket closed. Since v is equal to 1, we have constant returns to scale. Q is equal to 2s squared plus 3y squared. Q is equal to 2 bracket open vx bracket close squared plus 3 bracket open vy bracket close squared. Q is equal to 2 bracket open v squared x squared bracket close plus 3 bracket open v squared y squared bracket closed. Q is equal to v squared parenthesis open 2s squared plus 3y squared parenthesis closed. Q is equal to v squared q. V is equal to 2. This is an increasing returns to scale, but if q is equal to 2x raised to power 0.2 plus 3y raised to power 0.2, q is equal to 2 bracket open vx bracket close 0.2 plus 3 bracket open vy bracket close 0.2. Q is equal to 2 bracket open v raised to power 0.2 x raised to power 0.2 bracket closed plus 3 bracket open v raised to power 0.2 y raised to power 0.2 bracket closed. Q is equal to v raised to power 0.2 bracket open 2x raised to power 0.2 plus 3y raised to power 0.2 bracket closed. Q is equal to v raised to power 0.2 q. Since v is equal to 0.2, we have decreasing returns to scale. Study section summary. In this study section, you learned production and its processes. Also, you were exposed to the relationship between isoquant and isocost, which form the determinant of a firm's optimal production. While isoquant deals with combination of inputs used to produce a given level of output, isocost deals with the combination of these inputs given the firm's technology level as well as cost of each factor input. This is the end of section 3. Thanks for listening.